Just like anything else, air conditioning units and heat pumps can fail over time, and it seems like these things fail at the worst possible time, either when it's super hot outside, or in the case of a heat pump, even when it's really cold. Fortunately though, there's one very common point of failure, which is a bad capacitor. Now, if you're not sure if your issue is being caused by a bad capacitor, or if you're not sure how to replace one of these things, or even what type to pick to replace it with, we're going to cover all those things in this video. The most common symptom if you have a bad capacitor is the fan on the outside unit won't be turning. Now, you'll probably still hear the fan inside the house running, so that's a blower motor that actually forces all the air through your house, and that's different than the fan that's out here. This actually cools down the unit outside in order to help the heat exchange process. Now, while that's typically the capacitor, it can also be another issue, and probably the second most common issue is that the fan motor itself is bad, and usually that's due to bad bearings in the motor. You can tell if it's the motor and not the capacitor if you turn off the power at your breaker to your AC unit, and then you put something inside of this protective grate to try and spin the fan manually. If you can spin it and it doesn't seem to be grinding to a halt, or it doesn't seem to have a lot of resistance there, then it's probably not the bearings inside of the fan motor, and it's most likely the capacitor inside the condenser itself. All right, so I'm going to turn this on again. You can hear the compressor running, but the fan's not running at all. Earlier it had a whining sound, like a high-pitched buzz. And right now it's not doing that. But again, you don't see the fan blades spinning. They should be moving in a counterclockwise direction to exhaust the air out of the top. One way you can try and get this fan to kickstart, and this is not the safest thing, is to stick something down in here and kick the fan to the side and see if that will start it running. You can see the fan is still spinning, so I don't suspect that there's an issue with the bearings inside the fan. I think it's the capacitor. There were a couple other suggestions I thought I would try. One was to put a box fan on top of the condenser unit to try and exhaust enough air to spin the blades. In my case, this did not work, but if I had a smaller condenser unit, or if I had a more powerful fan, it may have been able to exhaust enough air to kickstart the fan. Another suggestion was to use a leaf blower to start the fan blades. Unfortunately, this method spins the blades the wrong way because you're forcing air down inside of the condenser versus from the bottom up. If you do end up jump starting the fan motor, make sure you monitor this closely. Make sure the fan is still running in order to cool the unit properly. Also monitor this for any odd sounds. Make sure it's not squealing or there's anything that could indicate there's a problem. If you do hear something like that, shut it off immediately. We've got the breaker turned off on the inside, but for good measure, we're also going to pull a fuse on this box outside. So the capacitor is going to be behind this panel here. All the electronics for this compressor are underneath this, so we're going to have to remove it to get access to it. So you can see the capacitor here. It's being held in place by this strap. Now first, before we remove this, we're not going to touch anything, but we are going to document what wires are plugged into which terminals on top of this capacitor. Even though the power is off, there's still power inside a capacitor. That's kind of what it does. That's its purpose. It stores energy to be used later, especially when you have applications like you're trying to start a motor from a standstill. Then you're going to need additional power in order to jump start or kickstart that motor, and the extra power is going to come from a capacitor. So while the power's off, that's great. We still need to discharge the capacitor to make it safe to handle. In our case, we're going to use a screwdriver, and best case would be to use a resistor, but we don't have a resistor, so we're going to use a screwdriver to short this and discharge the extra electricity. Make sure you use a screwdriver with an insulated handle and take all precautions. Again, if you're not comfortable with working with electricity, then I highly recommend you contact a professional to take care of this for you. If you have multiple terminals on top of the capacitor, make sure you touch the screwdriver or the resistor to all of the terminals. If the spade terminals are fully insulated or you can't touch all the terminals to short them out for some reason, then you'll need to disconnect the wires. Just be careful when you do that. In any case, you should always treat this like it still has power. So I'm going to keep these gloves on as I swap this out. And again, it's important to document the color of the wire that you disconnected from the specific terminal of the capacitor before you remove it. Now we're going to unscrew the strap. And we're going to have to hold this up so that way it doesn't fall. We can pull this out. You can see that there's multiple places to attach the wires to these terminals. It doesn't really matter which one of these points on each of the terminals you connect it to, just as long as you connect the right wire to the right terminal. So again, in our case, blue was connected to fan, so either of these terminals would work. Some telltale signs to look for to see if a capacitor is bad is whether or not these are leaking. So sometimes when these go bad, they'll leak out oil or another liquid that will be on the outside of the case. And if you see that in your case, then the capacitor is absolutely bad and you need to replace it. Another thing to look for is if the case is bulging or if it's cracked in any way. That's another clear indication that you need to replace your capacitor. And while this capacitor is absolutely bad, it doesn't really look bad. So just inspecting these visually isn't a definitive way to tell if these are bad and need to be replaced. You either have to test them or replace them to find out. Now, I'm not going to go through the process of showing you how to test one of these to determine if they're bad or not. One reason for this is because these tend to behave differently, or they can behave differently if they're under load versus removed from the unit. And obviously the safest way to test one of these is if your air conditioner unit is off. The other reason is these tend to be really inexpensive. This dual run capacitor I was able to pick up off of Amazon for about 20 bucks. So at the end of the day, if it didn't solve my problem, I'd only be out 20 bucks and I'd still have a brand new component to replace an older component that's been wearing out that I'd have to replace eventually anyway. When you're choosing a replacement capacitor, there are two main values you need to keep in mind. The first one is the microfarad rating, and that's the value that's next to what looks like an upside down H and a capital F. That just tells you how much extra energy the capacitor can store for on-demand needs. So for example, when you're starting your fan motor needs an extra burst of energy, and that extra burst of energy is going to come from your capacitor. And depending on the model of air conditioner you need, that value is going to be different. Now, there are capacitors to both keep your air conditioner running and to start the motor. So depending on what model air conditioner or heat pump you have, you may have one or two different capacitors that make the system run. If you only have one capacitor and that capacitor has a rating on the front with two different values, like I have here, this says 60 plus 7.5, that means this is a dual run capacitor, and this not only helps start the motor, which is that 7.5 value, but it also helps keep the compressor running, which is that first number. Another way to tell if you have a dual run capacitor is by the number of terminals on the top. For a dual run capacitor, you're going to have more than two, and one is going to control the fan and the other one's going to be used for the system. The other value you need to pay attention to is the voltage rating. So you're either going to typically see a 370 volt rating or a 440 volt rating, and you need to make sure you're replacing the capacitor that is in your system with the correct value. Now, if you can only find a capacitor that's rated for 440 volts and your capacitor is rated for 370 volts, then that should be totally fine. The 440 volt capacitor should be able to take care of the 370 volt need just fine, but you never want to go the opposite direction because you're going to overload it. One more piece of advice is to look for a capacitor that's roughly the same physical size, because they do make capacitors that have different dimensions. So if you pick a capacitor that is a lot different in size, say it's taller and skinnier than the one that's coming out of your system, then you might have a harder time replacing that capacitor with the new one because the strap might not be able to fit just right in order to hold the capacitor in place, or it might be too tall to go into the space. So here's the old one, here's the new one. We've got fan, common, and HERM or HERM. I'm gonna stick this in here. Since I just pulled this out of the box, it doesn't have any electricity built up in it. So I'm gonna connect it up without gloves, which will just make it easier since this bolt is really small. Tighten it down. Gonna connect blue to our fan, red to our common, and then we're gonna connect yellow to the last terminal here. Then I'm gonna reinstall this cover. Bolts don't have to be super tight, just need to be snug. I'm going to put this back in, close that. We flip the breaker back on, and now we're going to go turn on our AC and see what happens. The fan motor should start spinning if this worked. If this video was helpful to you, be sure to hit the like button, and also check out this other video next. I'm sure you'll like it too. All right, thanks for watching. I'll see you in the next one.